Hi, dear friends. I hope you are doing well. Thank you for choosing our channel to learn Python. Today we have a great topic. We want to talk about sets in Python. Introduction to Python sets. A set in Python is a special type of collection that has some unique features. What features? One, unordered. The elements in a set do not have a specific order. What does it mean? It means that when you add items to a set, they can appear in any order. The second feature is unique elements. A set can only contain unique items. If you try to add the same item more than once, it will only keep one copy. This makes sets great for eliminating duplicates. We have a set here. My list equals 1, 2, 3, 4. Okay, this is not set, this is a list, and I want to have a set from my list. So I have variable my set equals set my list. So when I use set and I apply it to my list, the result should be like that. 1, 2, 3, 4, 5, 6. There is no two items are the same. Despite the fact that in our list we have 4 for 2 time and 5 2 time, but the result for set doesn't contain any copy. Set operations. Python sets support operations like union, it means being joined, intersection, difference, and symmetric difference. Let's see what they are. So we have set A including 1, 2, 3, set B 3, 4, 5, and I want to union them or combine all the unique elements from both sets. Union set equals set A union set B. It means you add set B to set A, but it shouldn't contain a repeated number. You can see in set A we have a 3 and in set B we have 3, and it just keep one, not both of them. So the result 1, 2, 3, 4, and 5. Let's go for intersection. The intersection of two sets gives you a new set that contains only the elements that are present in both sets. Okay, 1, 2, 3, 3, 4, 5. The only elements that are present in both sets is 3. So intersection set A and B, and the result would be just 3. Let's go for different set. Show you the elements that are in the first set but not in the second set. We just have a 3 in the second set, so the result just would be 1 and 2. And we have symmetric difference. Gives you a set of elements that are in either of the sets but not in both. Okay, we have 3 in A and B in both. We don't need it. The result is just 1 and 2 and 4 and 5. We have set methods. We can add, remove, discard, pop, and declare our set. We have a set here. My set is 1, 2, 3. I want to add 4 to my set, so my set.add, and then I print it. So the result should be 1, 2, 3, and 4. I want to discard one item from my set. For example, I want to remove 2 from my set. My set that discard 2 and print my set. So the result is just 1, 3, 4. There is no 2. And I want to remove a random element from the set. Here I mentioned which number I want to remove, but a random one. I use pop, myset.pop, and it removed a random one. You can see here the random one. I ask for the removed item. It tells me the removed item is 1, the number 1, and I ask it to print the set. The set is just 3 and 4 because here we removed the 2 as well. So the remain set is containing 3 and 4. So we use pop for random remove. And I want to clear my set, the whole set. I use my set.clear and it clears all my sets. Let's check frozen sets. A frozen set is an immutable version of a set, meaning its element cannot be changed after creation. My frozen set equals frozen set. If I use the frozen set here, it means I can't change 1, 2, 3, and 4. And for example, I want to add 5 to my frozen set, and this will raise an attribute error here. So when I run it, you can see there is an error. Let's check set membership testing. Use the in keyword to check if an element exists in a set or not. My set is 1, 2, 3, 4, 5, and I want to check, for example, 3 is in my set or not. I say print 3 in my set, print 6 in my set. I have 3 in my set, so the result should be true, and I don't have 6 in my set, so the result is false. Let's check iterating through a set. You can iterate over a set using a for loop to access each element. My set is 1 to 5. For element in my set, print the element. And when I run the code, I can see my elements in the set. Set comparisons. Sets can be compared using comparison operators to check for subset, superset, or equality. For example, I have set A 1, 2, 3 and set B 1, 2, 3, 4, 5. Okay, print set A fewer than or lower than set B. It is true because set A has less items than B. So the result is true here. Set B bigger than set A. It means that B is a superset. For the previous one, A is a subset of set B and B is a superset of set A. Since B is a superset, the result is true. And print set A equals 1, 2, 3, and it checks set A. Set A is including 1, 2, 3, so it equals the set that we have in our code, so the result is true. For example, if I change that to 4 and run the code, we can see here is written false. And let's check the last thing, applications of sets. Sets are commonly used for removing duplicates, membership testing, and performing set operations in data processing. I have at least 1 to 5 and removing duplicates from a list. I want to remove, for example, 2, 2. We have 2, 4 here. Unique items equals set my list. And when I set it and run it, the result is just 1, 2 and 1, 4. And there is no duplicate items in my set. Thank you for being with me, and I hope you enjoy the lesson.